Welcome back, folks. Today we're going to be covering some familiar ground here, and that's going to be factoring quadratic equations. So let's start out by asking ourselves, what does it mean to factor? And the way we're going to be explaining factoring is removing like terms, or removing parts of like terms. Removing parts of like terms. And I want you to remember that for binomials, foiling and unfoiling, or factoring, are two sides of the same coin. So for example, if we had something like x plus 3 times x plus 2, what would we do? We'd FOIL. We'd do our first two together, we'd do our outer two together, we'd do our inner two terms, and our last two terms. We'd multiply all of these together to find what our equation would be. In this case, this would be x squared plus 5x plus 6. On the flip side, we can unfoil. If we were given x squared plus 5x plus 6, we could go, okay, what do we need to do to get this back into the form of x plus 3 times x plus 2? This process of going from the complete quadratic back into two monomials that are being multiplied, that is factoring. Let's do a review of what our steps for factoring are. Our first step is to make an ACB chart. Now, some of you might have learned other methods, such as a star chart. Any of those work as long as we get to the right answer. However, I'm going to be teaching us ACB charts. What does this mean? It means we multiply A and C together, so 2 and 12 together. So we get 24 on one side. We're going to look for factors of 24, multiplicative factors of 24 that add up to 10. We would look at this, we'd say 24 and 1 isn't going to work. Negative 24 and negative 1 isn't going to work. We'd keep going until we get to 6 and 4, because 6 and 4 add together to make 10. Step 2 is going to be expand your B term. So instead of writing this as 10x now, we're going to split that up into 6x and 4x. So this will become 2x squared plus 6x plus 4x plus 12. From here, we put parentheses around the last two terms and the first two terms, and step 3 is going to be factor whatever we can out of each parentheses. In this case, what can we factor out of 2x squared plus 6x? Well, each of these terms has an x, and each of them is divisible by 2. So we can factor out at 2x, and we're left with 2x squared divided by 2x is just x, and 6x divided by 2x is 3. For the other equation, we have no x's we can factor out. Looks like all we can divide by is 4. So we're going to divide by 4, and we'll be left with x plus 3. Step 4 is going to be factor out the remaining parentheses. Or in other words, we combine our coefficients for each of these into one answer, 2x plus 4, and we combine our second two, x plus 3, into a second term. Factor those out. Step 5, factor anything remaining if needed. So in this case, we have a 2x and we have a 4. Both of these terms are divisible by 2, so we can pull a 2 out in front, and we're left with x plus 2 times x plus 3. Step 6 is going to be check your answer. So in this case, let's follow these back in. Let's make sure we end up with 2x squared plus 10x plus 12. So going in reverse, we're going to start by FOILing x plus 2 into x plus 3. That should give you 2 times x squared plus 3x plus 2x plus 6. And then when we distribute this 2 in, we're left with 2x squared plus 10x plus 12. So we're good to go. Now some of you may remember we have a shortcut in here that allows us to go straight from the ACB chart all the way down to this part of the answer here. You can only use that shortcut when your leading coefficient, when your A term, is equal to 1. Otherwise, do not use that. Right, let's do a couple of practice problems now. I'll do one more and then we'll have you do some of these other ones. Starting off with this one, we have x squared plus 7x plus 10. So we're going to start by making an ACB chart. A times C is 10. We're looking for factors of 10 that add up to 7. In this case, factors of 5 and 2 add up to 7. So from this, we could use the shortcut. We think our answer is going to be x plus 5 times x plus 2. But let's expand this out and make sure that works. We have x squared plus 5x plus 2x plus 10. We're going to throw parentheses around each term. Factor out what we can, so we factor out an x. We're left with x plus 5. We factor out a 2. We're left with x plus 5. So our two inner terms combine, and our two remaining terms are the other equations. So our answer is x plus 2 times x plus 5. And there we have our answers. They match what the shortcut said. Now go ahead and do problem 2. What is our factored form for this going to be? For this one, we're looking for factors of minus 15 that add up to be 2. We go through our list, we find that minus 3 times positive 5 will give us negative 15, but it will add up to 2. So we can go through all of these steps, or we can use the shortcut. Either way, your solution will come out to be x minus 3 times x plus 5. This last one is a little bit more tricky. Why is that? Well, we have no b term. So let's make sure to rewrite this as x squared plus 0x minus 36. And now when we do our ACB chart, we're looking for factors of minus 36 that add up to be 0. Go ahead and do the rest of this problem. Our factors of minus 36 that add up to 0 are going to be positive 6 and negative 6. So we're going to substitute those in. You get x squared plus 6x minus 6x minus 36. We're going to factor these, so we're going to put parentheses around, pull an x out of the first one, we're left with x plus 6, and we'll pull a minus 6 out of the second one to get x plus 6. And so our answers are x minus 6 times x plus 6. All right, we have some extra practice problems here. Let's make sure we understand how to do couple with values for a. So I'll do 4 and then we'll have you do 5. For this one, we're looking for factors of a times c, or 24, that add up to minus 14. So we're looking for factors of negative 24 that add up to minus 14. Let's see, so we're going to need negative values here. Something like 6 and 4 perhaps. The answer that'll work for this is we're looking for minus 12 and minus 2. Minus 12 times minus 2 multiply together to make 24. They add together to make minus 14. So now we're going to substitute those in. I'm going to put my 2 with my minus 2 and my 12 with my minus 12. That should make my life easier. This becomes 2x squared minus 2x minus 12x plus 12. Let's go ahead and throw parentheses around. From this first equation, we can pull out a 2 and an x, and we're left with x minus 1. From the second equation, we want x minus 1 on the inside, so we need to flip this plus sign into a minus sign, meaning we're going to factor out not just a 12, but a minus 12. And that'll leave us with x minus 1. So our solution here is 2x minus 12 times x minus 1. Except we're not done. We still have a factor of 2 we can pull out of this first term, meaning our answer is going to be 2 times x minus 6 times x minus 1. Go ahead and try problem 5. Find out what the answer in factored form will be. For this one, we're looking for factors of 12 that add up to 13. So that's going to be 12 and 1. When we do this out, we're going to get 2x squared plus 12x plus x plus 6. Throw everything in parentheses, and let's see what we can pull out. From this first one, we pull out a 2x, and that leaves us with x plus 6. For our second one, we pull out nothing, meaning we pull out a 1. And we're left with x plus 6. Meaning our solution for this is 2x plus 1 times x plus 6. So this is a basic review of factoring. If you're feeling uncomfortable with it, we have some extra problems here for you all to try out. However, we're going to jump ahead to a couple of special cases that we can look at. A couple of things to keep your eye out for. It's okay if you don't see these, but if you do, it'll make your life a little bit easier. So let's start by foiling out some of these. X plus 3 times x minus 3 would become x squared plus 3x minus 3x minus 9. Meaning that our end answer for this would be x squared minus 9. The second equation, if we multiply it, what do we get? Well, we get 4x squared minus 10x plus 10x minus 25. Or our answer is, this is 4x squared minus 25. Right. We'll do one more. What do we notice is the same or different about each of these? Each of our first terms are the same, and our second terms are only different by them being added or subtracted. So let's go ahead and try this one. We'll get 16x squared minus 12x plus 12x minus 9. So that leaves us with 16x squared minus 9. What's the rule here? Well, the rule is, if you have ax squared minus some value of c, then you can factor that, and this goes the other way. If you're foiling these out, this factors to become whatever the square root of your coefficient is. So square root of 16 would be 4 times x plus the square root of c. So in this case, square root of 16 would be 4x plus square root of 9 is 3 times square root of a times x minus the square root of c. So in other words, if we're looking at this, we can take the square root of our coefficient and our constant, and we can say our terms are going to be 1 plus the other and 1 minus the other, just like we're seeing in these problems. We have 16x minus 9. Our answer is 16, or square root of 16 is 4, square root of 9 is 3. And we have 4x plus 3, 4x minus 3. This is our first special case. What about our second special case? When we're looking at all of these, what do we see? This is the same term repeated each time. X plus 3, x plus 3. 2x plus 5, 2x plus 5. 4x plus 3, 4x plus 3. Let's see what happens when we expand these out. For this first one, we get x squared plus 3x plus 3x plus 9. Or this is the same thing as x squared plus 2 times 3x plus 9, or x squared plus 6x plus 9. In the second equation, when we expand it, we get 4x plus 10x plus 10x plus 25. Or in other words, this is 4x squared plus 2 times 10x plus 25, or this is equal to 4x squared plus 20x plus 25. And we have one more of these, 4x plus 3 times 4x plus 3. This becomes 16x plus 12x plus 12x plus 9. Or 16x plus 2 times 12x plus 9. Or this is 16x squared. So we're missing a squared here. This is 16x squared plus 24x plus 9. What's our rule here? How does our last number relate to what we're adding? Our last number is that number squared. And what about the coefficient? Well, our coefficient is again just the square root of the square of our first term. So if we see something in a form where we have two perfect squares in here, and we have something in the middle which is 2 times those square roots, our rule is, or in other words, ax plus b times ax plus b, just like we have here, this is going to become a squared x. So we're going to square the first term. We're going to multiply 2 times our coefficients for both sides and put that to x. And then we're going to square our b value, not c, our b value. This is a little confusing, but what it says is we take 4, we square it to get 16, then we get 4 times 3 and multiply it by 2. So 12 times 2 to get 24x. And then to get our last term, 3 times 3, or 9. One last case here. That is when we're subtracting the same thing. So what does this become? This becomes x squared minus 3x plus 9. Or this is x squared minus 2 times 3x plus 9. Or x squared minus 6x plus 9. Let's try this again with the third one here. We have 4x minus 3, 4x minus 3. So this becomes 16x squared minus 12x plus 9. Or this is 16x squared minus 2 times 24. 2 times 12x times 12x plus 9. Or 16x squared minus 24x plus 9. So again, our rule is if we have ax, but this time we're subtracting a number twice, what does this give us? It gives us some value squared times x squared. This time we subtract our middle term, 2 times a times b, and then our second term will be squared. Or in other words, looking at this, our leading coefficient for this last problem is 4 squared. It's 16. Then we have minus 2 times 4 times 3. So 2 times 4 times 3 is minus 24. And negative 3 times negative 3 gives us positive 9. Or in other words, if you see something in this form where we have a squared on the front and the back and a minus in the middle, we're going to have to keep an eye out for that. If they're added, we're going to want to do adding together. And if we have no middle term, that means we're just splitting the two up. Let's give you a couple of practice problems to see how this goes. For something like x squared minus 9. 9 is unique because square root of 9 is 3. And we have no middle term here, no b term. So we're going to be looking at this. If we go back up to our special cases, we have some number minus another square. That means we're going to add one and subtract the other. So this becomes x plus 3 times x minus 3. For this next one, we have a minus sign right here, and 9 is just 3 squared. So again, we're looking at this, we see a square and we see a square. We have the minus, making this special case 3, meaning that this will be x minus 3 and x minus 3. Go ahead and try problem 3. What will our factoring be? For this one, 25 is just 5 squared, and 10 is 5 times 2. So we know this is a prime case for special case 2. Looking back at special case 2, what does this equal? It equals x plus b. We have no a because we have an a value of 1. So this is going to be x plus 5 squared. So this will be x plus 5 times x plus 5. Finally, we have some quick review of distributing and factoring. Remember, when we distribute, we multiply everything together, but the exponents get added. So if we were to distribute this in, we'd get minus 2x cubed times y to the 4th times 7x to the 8th y squared plus minus 2x cubed y to the 4th times 3xy to the 11th, and so on. What does this become? Well, minus 2 times 7 gives us minus 14. But remember, when we're multiplying exponents together, x cubed times x to the 8th, those add together. So this becomes x to the 3 plus 8, or this becomes x to the 11. So this is x to the 11 and y to the 4 plus 2, or 6. Our second term will be minus 2 times 3, so minus 6. We have 3 up here. We have a implied 1, right? Anytime we just have x, that's x to the power of 1. So this becomes 3 plus 1, or x to the 4th. Y becomes 4 plus 11. So this is y to the 15th. And then we have plus 1, so we're just going to have our last term. X cubed, y to the 4th. Go ahead and distribute this monomial. For this one, when we distribute it in, we get 2 times 4, so that is 8. X to the 1 times x squared will be x to the 1 plus 2, or 3. And we have nothing to attach y to, so y stays by itself. Then we'll have minus 2 times 7 will give us 14. We have nothing to have x attach onto, so it's going to be by itself. We have 3 y's and we have 4 y's, making that 7 y's, z to the 8th. And finally, let's look at some factoring. All we're going to do for these is figure out what we can pull out of each term. So looking at our constants, none of those have any common factors. We can't pull out a constant. Do all of these terms have an x though? They all have a single x. So we're going to pull out a single x. And each of these has a single y, so we're going to divide each of them by a single y. What are we left with? Well, we didn't change the constants. We pulled out one x. We pulled out one y. We'll go on to our next term. Pulled out no constants. We pulled out one x, so there's no more x's, and one y. So we're left with one y. And we have 3. We subtract one x, so we're left with x squared. and we're left with no y's. All right, how would we factor this problem? For this one, what is our common term? Looks like we have a 2 we can divide out and an x. So we'll divide a 2 into x out. 8 divided by 2 will leave us with 4. We're left with 6 x's and 1 y. Minus 6 divided by 2 will leave us with minus 3, and we'll pull out an x. And then for this last one, we'll divide 4 by 2 to get 2. We have no more x's, so we pulled that last one out, and we're left with y. And there we have factoring of quadratics.